Direct and inverse variation. Let's talk about what direct variation looks like. Direct variation will be described this way. Let's say y varies directly with x. Okay, so this will be interpreted as y will equal whatever x is after it's multiplied by some number. Y will equal whatever x is after it is multiplied by some number. So basically, x as x gets bigger and bigger, and you multiply times the number, y will end up getting bigger and bigger as well. So direct variation. Let's say we have y varies directly with x squared. This will be interpreted as y will equal whatever x squared is after it's multiplied by a constant. And I'm using k for constant, but you can use any letter of the alphabet for constant. And also people ask, why not use the letter C? No, we can't. I'm just using k. It's traditionally used k for the constant. Let's see. Next, let's talk about inverse. Inverse variation. Y varies inversely with x. So y equals x after the inverse is taken. Okay, so if x was 4, y would equal 1/4. If x was 2/3, y would equal 3/2 after some number or constant is multiplied with it. Now, because there's another constant, we can combine the constant as being multiplied with the 1 over x by simply changing this to k over 1 times 1 over x. And that becomes k over x as your simplified form. So, and you can do combinations with this. You can do directly and inversely. So y varies directly with x and inversely with z. Okay, so y varies directly with x and inversely with z. So what this will be is y equals whatever x is, okay, and inversely with z. So this will be over z. So z will be dividing while x is multiplying. And there will be a constant, so times k. And this can be simplified to look like, see, we'll make that k over 1 times x over z. K times x is kx, and 1 times z is z. So this can be rewritten this way. Okay, so let's tackle these problems. The distance varies directly with the speed. Distance varies directly with the speed. Distance, we use the letter D. Varies directly with the speed. We'll use S for speed. So distance equals the speed after it's multiplied times some constant. So that is distance varies directly with speed. Next, the distance travels 150 while the speed is 60. So distance is 150, so we'll put 150 here for D. And the speed is 60, we'll put 60 in for S. And the K, the constant, is still unknown. Now we're going to find K in just a minute by solving. We're going to divide both sides by 60. And this will give us K. The zeros cancel, and we get 15 over 6. I want to simplify this by dividing by 3. And 15 divided by 3 is 5. 6 divided by 3 is 2. So we have our constant is actually 5 over 2. So now we know distance, we know speed, and we know constant. This last problem says, well, what is the distance if the speed is now 50? Well, we start back again with d equals ks. And we're looking for the distance, so that remains the letter d. The k we know is 5 over 2, so we'll put 5 over 2 here. And the speed is 50, so we'll put a 50 here. Now to multiply these two numbers, we need to make them both fractions. So 5 over 2 multiplied with 50 over 1. And when you multiply fractions, you multiply numerators. So 5 times 50 is 250, and 2 times 1 is 2. Now this can be simplified. 250 divided by 2 is going to be 125, and that's going to be miles. Okay, let's try number 2. The price varies inversely with demand. The price varies inversely with demand. So price equals the demand, but since it's inversely, it'll be 1 over the demand. And we will not forget our constant. And we'll rewrite this as P equals K over D. That's in a simplified form. Next, we're told that the price is $2.50 while the demand is $100. So price will be $2.50 and our demand is $100. So the question is, what would the K be? Well, these denominators, 100, we can get rid of this by multiplying on both sides by the denominator. So let's multiply 250. Sorry, this side will multiply by 100. The denominators will go away. Multiply this side by 100, because it balances the equation. Whether you're doing one side, you're doing the other. So the 100s will go away. And when we multiply this, we'll get 2, 5, and 3 zeros. That's 25,000 there. So now we have our K. So let's go back. We know the price, we have our dollars, and we have our K. Now let's do the last part. The last part, that we know our P equals K over D. Then we'll say, well, how many units will it be in demand? So we're looking for D. If the price is $200. Well, let's put in $200 for the price. And the K we know is going to be 25,000. And we're looking for demand. Now, once again, these denominators are not good. So we're going to get rid of this denominator of D. And the way that we're going to get rid of the denominator of D is by multiplying both sides by D. So multiply by D here, and then multiply by D there. Maybe I could have put that D on the other side. So I guess I will in the next step. 200 times D. These D's cancel, and we get 25,000. Now I'll divide both sides by 200. And we'll get D equals, all these zeros cancel out. We're left with 250 over 2. And 250 over 2, that'll be 125. And that's our demand. And demands are basically orders. These are orders. So they're getting 225 orders. Next, the area of a circle varies directly with the radius squared. The area of a circle varies directly with the radius squared. So the area equals the radius squared after it's multiplied by some constant. So that's the first part. Next, the area is 6.75 centimeters squared, while the radius is 1.5 centimeters. All right, so the area, 6.75 equals the K right here, and the radius is 1.5. So that's 1.5 to the second power. Now let's start off with the 1.5 to the second power here. 1.5 times 1.5 is going to be 2.25. Okay. Then from there, to solve for k, we're going to divide both sides by 2.25. And I think this goes in there 3 times. So this will be k. So our k is 3. So now we have everything. We have the area, we have the radius, and we have the k. So everything's done there. The last part is, what will the area be if the radius is 2? So let's start again. A equals the radius squared after multiplied by a constant. So we'll look for the area. So this is A. We know our constant is 3. And we have a radius of 2. So we put 2 squared. Well, 2 squared is the same thing as 2 times 2. So what we have now is 3 times 2 times 2. And that is an area of 12. In particular, 12 centimeters squared, because area here is in centimeters squared when we talk about area. Number 4, to preserve the volume inside a cone, the height must vary inversely with the radius squared. So the volume inside of a cone, okay, here's where it starts. The height must vary inversely with the radius squared, the height. So height, I'll use the letter H. Height must vary inversely with the radius squared. So here's the radius squared, and inversely, I'll put a 1 on top. Okay, so that's the height very inversely with the radius squared, and then always multiply by a constant. So let's put all this together. This will be H equals K over R squared. All right, so we have that part. That's good. The next part says the height is 10 while the radius is 2. The height is 10 while the radius is 2. So the height is 10 while the radius is 2. Well, the radius being 2, which will be squared, will make 4. And now I will get rid of the denominator of 4 by multiplying both sides by 4. Oops, it's hard to see. Bring that up. So when I multiply both sides by 4, this side gives me just k, but this side gives me 40. And now I know that my k is 40. So I have my height is 10, my radius is 2, and my k is 40. Finally, what will the height be if the radius is 1 foot to preserve the volume? Well, let's write the formula. We have H equals K over R squared. And we're looking for the height if the radius is going to be 1. So looking for height, and the radius is 1. So it'll be 1 squared. The K is 40, so we'll put 40 here. 1 squared is still 1. And 40 divided by 1 is going to be 40. And the height before, oh, they didn't tell us. I guess everything is in feet. So this will be 40